Hello, and welcome back to our channel. Today, we're diving into the fascinating world of space exploration and pondering the question, could Jupiter become a star? This colossal gas giant, the largest planet in our solar system, is primarily composed of hydrogen and helium, the same key ingredients found in stars. This fact alone sparks our curiosity, leading us to explore the intriguing possibility of Jupiter transforming into a star. But what does it take for a planet to turn into a star? It's all about the process of nuclear fusion, where hydrogen atoms fuse together to release energy. But there's a catch. For this to occur, Jupiter would need to have significantly more mass. Despite falling short in this aspect, Jupiter continues to play a crucial role in our cosmic neighborhood. So buckle up as we journey through the cosmos and explore the possibilities. Jupiter, the largest planet in our solar system, is a gas giant primarily composed of hydrogen and helium. Now, if you're a space enthusiast, you might have noticed a little something interesting here. Hydrogen and helium, they're not just random elements. They're the exact elements found at the heart of our sun and other stars throughout the universe. Now, let's dive a little deeper. Stars in their most basic form are essentially giant glowing balls of gas. They're powered by nuclear fusion, a process that occurs when the intense heat and pressure within the star force hydrogen atoms to come together and form helium. This process releases a tremendous amount of energy, causing the star to shine brightly in the sky. So, if stars are made of hydrogen and helium, and Jupiter is made of hydrogen and helium, well, you can see where this is going. Could Jupiter, our beloved gas giant, actually have the potential to become a star? Well, to answer that question, we need to take a closer look at Jupiter. While it's true that Jupiter shares some key characteristics with stars, there are some crucial differences. For one, Jupiter's mass is only about 1,000th that of the Sun. This means that Jupiter simply doesn't have the gravitational pull necessary to trigger the process of nuclear fusion. In addition, Jupiter's composition, while similar to that of a star, is not exactly the same. Jupiter has a much higher proportion of heavier elements, such as carbon, nitrogen, and oxygen, compared to stars. These heavier elements could impede the process of nuclear fusion, making it unlikely for Jupiter to ignite as a star. These elements, hydrogen and helium, are also found in stars, which brings us to the exciting question, could Jupiter become a star? As fascinating as the thought might be, the reality is that Jupiter, as it stands, lacks the necessary conditions to transform into a star. But isn't it intriguing to ponder the possibilities? Stars are born through a process called nuclear fusion, where hydrogen atoms fuse together to release energy. Now, let's unravel the mystery of nuclear fusion. At its core, nuclear fusion is a reaction in which two or more atomic nuclei collide at a very high speed and join to form a new type of atomic nucleus. Imagine a bustling city during peak hour traffic. Cars, representing atomic nuclei, move at high speeds, colliding and merging to form bigger vehicles or, in our case, a different type of atomic nucleus. This process, however, isn't as chaotic as it sounds. It's a dance choreographed by the laws of nature, happening at the atomic level. Now, to create a star, nuclear fusion must happen on an enormous scale. Picture it like this. In the heart of a star, every second, millions of hydrogen atoms are fusing together, releasing copious amounts of energy. This energy travels outward from the core, fighting against the force of gravity that wants to pull everything inward. The balance between these two forces is what allows a star to maintain its size and shine brightly in the cosmos. But what does nuclear fusion have to do with Jupiter becoming a star? Well, the primary components of Jupiter are hydrogen and helium, the same elements that power stars. Hypothetically, if Jupiter could achieve the extremely high temperatures and pressures needed for nuclear fusion, it could begin to glow, essentially turning into a star. However, there's a catch. Jupiter would need to accumulate more mass, about 80 times its current size, to kickstart and sustain nuclear fusion. So, while it's a fascinating concept, the reality is a little more complex and less likely. This process powers the star and allows it to shine brightly in the sky. So, next time you gaze up at the night sky, remember the incredible process of nuclear fusion that allows those stars to shine so brilliantly. However, for Jupiter to become a star, it would need to have significantly more mass to sustain nuclear fusion. Now let's put things into perspective. Jupiter is colossal by planetary standards. It's over 1,000 times the volume of Earth. But when it comes to stars, even our own sun, Jupiter is pretty much a lightweight. Stars, like our sun, are powered by nuclear fusion. This is a process where hydrogen atoms come together under immense pressure and temperature to form helium, releasing a tremendous amount of energy in the process. In essence, it's this energy that lights up a star and allows it to shine so brilliantly in the night sky. But for this fusion to occur, there's a catch. The celestial body must have a certain threshold of mass. This mass creates the necessary gravitational pressure and heat in the core to trigger and sustain nuclear fusion. In terms of numbers, a celestial body needs to be about 80 times the mass of Jupiter to have enough pressure and heat to ignite nuclear fusion. To put it another way, Jupiter would need to be about 7% the mass of our Sun to qualify as a star. However, Jupiter's mass is only about 1,000th that of the Sun. So, despite being the heavyweight champion of our solar system, Jupiter is still far from reaching the mass required to jumpstart the process of nuclear fusion. This reality puts a damper on our imaginative idea of Jupiter transforming into a star. It's like expecting a firefly to shine as brightly as a lighthouse. It's simply not going to happen. So, while it's fun to entertain the idea of a second sun in our solar system, the laws of physics have the final say. Jupiter, as mighty and impressive as it is, will remain a planet. It's a gas giant with a significant influence on our cosmic neighborhood, but it lacks the mass necessary to ignite into a star. Unfortunately, Jupiter falls short in this aspect and lacks the necessary mass to ignite as a star. So, while it's a captivating idea to imagine Jupiter as a star, the reality is that it will remain a planet in our solar system. This grand gas giant, the largest planet in our neighborhood, has a significance that extends far beyond its impressive size. Jupiter plays a pivotal role in maintaining the balance of our solar system. Its enormous mass, over 2.5 times the mass of all the other planets combined, exerts a strong gravitational pull. This gravitational force has a profound influence on the paths of other objects within our cosmic vicinity, often deflecting comets and asteroids that could potentially pose a threat to Earth. In addition to acting as a celestial bodyguard, Jupiter's gravitational influence also helps to stabilize the orbits of the other planets in our solar system. Without Jupiter's gravitational anchor, the inner planets, including our own Earth, might be thrown into chaos. But Jupiter's influence isn't limited to its gravitational pull. The planet's intense magnetic field, larger than the Sun's, creates a vast region of space known as the Jupiter magnetosphere. This magnetosphere is so large that the Sun and its solar wind have to flow around it, creating a bow shock much like a boat moving through water. Jupiter's magnetosphere is also responsible for some of the most spectacular light shows in our solar system. The charged particles trapped in Jupiter's magnetic field interact with the planet's atmosphere to create bright auroras, akin to our northern and southern lights here on Earth. In the grand scheme of our solar system, Jupiter is more than just a planet. It's a guardian and a spectacle, an influencer of orbits and a creator of cosmic light shows. It may not have the fiery glow of a star, but its impact on our cosmic neighborhood is undeniable. Playing a crucial role in shaping the dynamics of our cosmic neighborhood, Jupiter continues to fascinate us with its immense size and powerful influence. So the next time you gaze up at the night sky and spot Jupiter, remember the significant role this gas giant plays in our corner of the cosmos. Thank you for joining us on this cosmic journey. We've delved into the intriguing world of Jupiter, exploring its gaseous composition and pondering its potential transformation into a star. We've learned that despite sharing elements with stars, Jupiter lacks the necessary mass to ignite the process of nuclear fusion. This process, which powers stars and allows them to shine brightly, is unfortunately out of reach for our gas giant. It's a captivating idea, yet the reality is that Jupiter will remain a planet, playing a significant role in shaping the dynamics of our cosmic neighborhood. We invite you to continue exploring the fascinating world of space with us. If you enjoyed this journey, please give us a thumbs up, share this video with your fellow space enthusiasts, and don't forget to hit that subscribe button for more intriguing insights into the wonders of the universe. Until next time, keep looking up at the stars.